Well, welcome back, everyone, and we're jumping into another lesson here. We're talking about materials and their strength, and we've already talked quite a bit about beam theory, and we've talked about yield strength, ultimate strength, and all these things. And the main thing is to remember, anytime you have a member and a force is applied to it, when that force comes in contact with that component, the fibers in that material are stressed, which cause deformation. And deformation, when that stress goes through, it builds a pressure up in it. And that's some of the things that we're looking at. And again, pressure equals force. It's what we're pushing down, the force on it, divided by the area of the component or the member, like this board, let's say, that's going straight across from these 2 points. Could be a bridge or something. You might be standing on the middle of it, okay? And that pressure and that, it's going to be that force divided by the area. So let's just remember that. But inside of these units of measurement, we've got to understand a few key components. How to be able to convert between standard units and metric units. You're going to see that a lot. You're going to go look up some information. You're looking for a yield strength. Again, yield strength is the point where there's a force and pressure placed on the material that is past its point of returning back to its normal shape. All right, it's being flexed, and when it hits that point of yield, it can't go back to its normal. It's been deformed, okay, at that point. So, again, yield strength, let's say you had it in a metric unit, and you want to know what it is in standard unit. You've got to be able to convert these back and forth, okay? So that's major. And I want to show you how to do it. But before we get too far along, bring that little example back up, and we say we got force coming down on this this little bridge, okay? Now, in standard, this force is going to be in pounds, okay? So if it's in the standard, it's going to be in pounds, as you see over here. Standard will be in pounds. Metric, the force is going to be in newtons, okay? And when I come up here, I want to show you up here, 1 pound is equal to 4.4482 newtons, okay? That's the conversion factor between pounds and newtons. And down here's the same conversion. It's just saying 1 newton is equal to 0.2248 pounds, okay? Then we'll get into pressure here in just a moment. Because when you have a force, you have the area, and again, in standard it's inches, square inches. And in metric, it's going to be meters square. All right. Now, you could have different things, but these are the standard ones we're working with. It's inches squared for standard. And some people have feet squared. You'll see that. We're using inches squared here. And then the metric, you could have millimeters squared, but we're using meter squared because 1 meter square, when you do pressure, a newton divided by a meter square is 1 Pascal. And that's a unit of pressure, and we're going to look at that here in just a minute. And that's what this is. This is a conversion factor between 1 pounds per square inch equals 6.895 pascals. That's the conversion factor. That's what we're going to look at. So, again, the force in standard units is going to be pounds, okay, for standard. All right, the newton is going to be for metric. That's the force that's coming down. That's going to provide the pressure whenever you figure out what the cross-sectional area is of the member, okay? So that's just real rough, real standard. So now, let's get into this conversion. Let's first do one that we all pretty much know, we've already done in class, is like 1 inch equals 25.4 millimeters. All right, so if you draw a line 1 inch and you draw one underneath that, 25.4 millimeters are the same exact length. It's just a different unit. So let's say, for instance, I had 10 inches, and I want to convert that into millimeter. Okay, I want to convert that to a millimeter. This is how you do it. Just put the 10 over 1, put you an equal sign, come over here, and then use your conversions. You got to find a conversion that has what you already have, because that's what you want to convert, is in inches. So right there's my inches, and I want to convert it into millimeters, which is this right here. So opposite of the 10 inch is where you put the 1 inch. The reason being is because I get to cancel out the inches. And what's left over of this conversion factor, I put it on the other side, 25.4 millimeters. So you notice what's left? The millimeter. So when you do this, 10 times 25.4, you just come straight across. That would be 254. All right. And then 1 times 1 is 1. Don't forget to bring that millimeter over, by the way. So 10 inches is equivalent to 254 millimeters. Simple, right? It's not bad. So let's go on here. Let's do this. Let's go backwards. Let's say I've got 50 millimeters, and I want to know what that is in inches. All right. So again, put the 50 over 1 equals, and I come up here and I've got millimeters, but I want inches, so there's my millimeters, and I need inches. So this is my conversion factor up here at the top. So opposite of the millimeter is where I put the millimeter. The reason being is it gets rid of the millimeter. You all see that? And what's left over of the conversion factor, I put it in the empty spot. And you could have something up here. I mean, it just depends on what you're doing here. But again, this is how this one worked out. So again, 5 times 1 equals 50. Bring your inches over and divide it by 1 times 25.4 is itself. So all you have to do, grab you a calculator, and again, 50 divided by 25.4 is 1.9685. So 50 millimeters is equivalent to 1.96, and I'll say 9, we'll round up, inches. Okay? So that is straightforward of how you do that. Let me get that off there so you can see it. So again, now let's get into some pressures or forces, let's say. So again, here is a beam coming across. I got a force coming down on this thing that is, we'll say, 200 pounds. All right, that's in standard. I want to know what that is in metric newtons. Okay? So, I come down here, 200 pounds divided by 1 equals, and I come over to this side, and I got to find my conversion factor. Well, you got 200 pounds here, so I got to find pounds. So here's a pounds, and here's a pounds, right? I can use either one of them. It does not matter, okay? So, let's go with this one. 1 pound, so if you put 1 pound on the bottom here, because I want those to be able to cross and cancel out. You all see that? And what's left of this conversion factor is 4.4482 newtons, okay? So, again, when we do this, you take 200 times 4.4482. Let me get my calculator back up here. Make it a little easier on us. 200 times 4.4482 equals 889.64. I'm running out of room there. 889.64 divided by 1 times 1, so it's itself. So 200, let me not minimize that. So 200 pounds is equivalent to 889.64 newtons. Okay? That's how it works. Not bad, is it? Not bad at all. So let's go through and we'll do this. I got 5,000 newtons, and I want to convert that into pounds. Okay? Into pounds. So I take again my 5,000 newtons, divide it by 1, equal. Come over here, and which one works? I got newtons, or I got newtons. These two formulas I can use, okay? So which one do I use? It doesn't matter. Let's use the top one up here just so I can show you a different little style of how to do it. I mean, you're going to divide instead of multiply like last time. But anyways, 500 newtons. So down here, I'm going to use this 4.4482 newtons because these cross out, and what's left over of my conversion factor goes to the top, which is 1 pound. That equals 5,000 times 1 is 5,000. And don't forget to bring over your pounds. And divide it by 1 times 4.4482 is itself, 4.4482. And ultimately that equals, let's bring our little calculator up. And it's always good to double check yourself on your calculations when you're doing this mathematically, just to make sure there's no discrepancies. It's always good to double check. So when we look at this, 5,000 newtons is equivalent to 1,124, and that's good, pounds. So basically 500 newtons is equal to 1,124 pounds. All right, so that is a unit of force, okay? That's how much force is being applied on the object. Now, let's take a look at pressure. So we've got a force, and it's making stress, causing deformation in our part. So now we got to find out how much pressure is in that part so that we can look up our material properties, its yield strength, its ultimate strength, and see if it can withstand the pressure that's being enforced on it. Okay? So let's do that right now. Okay? So the first thing that I want to do is, again, I want you all to make sure that you understand. Pressure equals force, which is either a pound or a newton, over an area, okay? And in standard, it's inches squared, be length times width. Metric, it's meter square. And the reason you were using meter square is because that is what we consider 1 Pascal, okay? So when we're doing this, let's say, for instance, let's do the standard first. So pressure, I've got, let's say, 500 pounds, okay, setting on top of a cross-section area that is, we'll say, 20 inches squared. Okay. So if I'm looking at this, very simple formula, very simple math, right? So we're going to take 500 divided by 20, and it's 25. So the pressure, and again, this was in pounds up here. So the pressure, and we bring that over, is going to be 25 pounds per square inch. That's where you get the PSI. All right, so it's pounds per divided by inches square. So it's pounds per square inch. So that's where we get 25 pounds per square inch. Is how much pressure is being applied at that point. So now, if we want to find out what 25 pounds PSI is, in the metric side, we got to do, oh, I should have brought that out of there. So now you can see it there. 500 pounds divided by 20 square inches is 25 PSI. But I want to find out what this is, convert it to a Pascal. And down here, here's our formula. Now, we already know what the pressure is. We just need to convert. So we got to go up here to our conversion scale. 1 PSI is equal to 6.895. So just take your 25, divide it by 1, 25 PSI, equals, and I need PSI, and I need pascals because it's what I'm going to. So this is my conversion factor. So what goes down in this section? Yeah, it's going to be 1 PSI, and the reason being is they're cross. I can actually eliminate that. All right, those cancel out. So what's left in this conversion factor is 6.895, and it goes up into this spot. It just automatically goes up there. It's the only spot for it. And it leaves us with pascals. Okay? So now, 25 times 6.895, we'll grab us a calculator, is 25 times 6.895, which equals 172 I'm just going to say 38. I rounded up. Divided by 1 times 1 is 1. So there's our answer. 25 PSI is equivalent to 172.38 pascals. Or it's the same equivalent as saying Newton over meter squared. That's what a Pascal is. Okay? So that's that portion of it. Let's do one more while we're in this. So we've got a pressure now. We've got a pressure now that is, we'll say, the pressure, and we've already got the pressure, so it'll be in pascals. We'll say we have 100. Well, actually, let's go a little further. Let's say we got 1,000,000. We got 1,000,000 Pascal pressure, okay? The same as saying 1,000,000 newtons over meter squared. That's what a Pascal. So we got 1,000,000 of those, and that's how much pressure we got. So I want to take and I want to find out exactly what this is here in inches or pounds per square inch. So again, we use our formula up here. We put 1,000,000 down here, and that's Pascal. Divide it by 1 equals Pascal. Pascal, PSI is what we're looking for. So Pascal would be down here on the bottom. PSI will be up here on top, because that's what will be left over. These will cancel out. Pascal 6.895, and PSI is 1, so equals, come down here. So again, it would be 1,000,000, and I've got that calculator up in your way too. Let me get that out of the way. 1,000,000 divided by, and it's going to be PSI tags along with it, 1,000,000 divided by 6.895, which ultimately equals, let's pull that calculator back up here for you. So again, clear that out. 1,000,000 divided by 6.895, and it equals 145,032. That's for, I'm just going to put that in there, PSI. Okay? So that 1 million pascals is equal to 145,032 PSI. And that is it's a lot of PSI. Okay? It's a lot of PSI. That's a lot of pressure there. So, real quick, 1 million is a big term to put in there. So, I want to convert that 1 million pascals into megapascals. Y'all remember that from last class? And again, from the base unit up to mega, again, you're going to have that stair step, right? Here's the base. Let me get this out of the way. There we go. So you got your base, comes up to deca, comes up to hecto, comes up to kilo, and then, let me clear that out. Then it goes up a couple more times, and it goes to mega. There's our mega, and this is base down here, and this is our deca, this is our hecto, this is our kilo, and then 1, 2, 3 up there. So our base unit is pascals. So again, it'd be 1, 2, 3, 4, 5, 6. 6. So saying 1 million pascals is equal to, there's your decimal, come over 6 places, 4, 5, 6, is equal to 1 megapascal. Okay? So that's the unit you'd read that one in. It would say 1 megapascal is equal to 145,032 PSI. Okay? So I hope that helps you guys. If you all need any help with this, please let me know, and I can help you. Again, this is just like last class. This is going to be very important because we're going to build on this as we go. Again, if you need help, let me know.